Hello, my name is Shibo. Today I want to talk about our group project, the Multiplayer Scene Simulator. So for this presentation, first we will talk about the goals of the project, then we will talk about the implementations like the vision, the sound, the lighting, sensors, and maybe some other thing about how to do the multiplayer for this game. And at last we'll have a demo for our project. So for the project description, the goal of our project is to create a multiplayer space simulator using the United 3D gaming engine. This game is cooperative, so you can start the game by yourself, or you can join other people's game, or you can just host the game to wait for other people to join your game. Usually we have two teams in the game. The players join a single team to define the allied forces from the enemy forces. Both allied and enemy forces include ships and turrets. To win the game, the allied team must beat all the enemies, destroy all the enemy shields and turrets, so they will win the game. Otherwise, they will lose the game. So when you start the game, the player will find themselves starts between the two turrets, and with their ship, they use the ship is you see the screenshot here. It's red, it's red and white, and the enemy ship is green and blue. So they push really ahead to them. So the player must defend their allied ship and turrets will successfully defeating the enemy ship and their turrets. So for the user turret is the purple one, and for the enemy turret is the red one. So for the implementation of the environment, since the game is in the space, and so we need a very large background, so we just draw by hand, use the software we call the software is the Affinity Photo Editor. We draw it by ourselves, so much draw that one. So so for the avatar models, we're including ship and turret operators. So they are freely available at the King website. So it's a very good website. You can download lots of 3D models here. And so for both team, the enemy team and for allied team, they both have 20 spaceship and 8 turrets. And to make the environment rich, we add a lot of plants and some stars in your background to make it look well as field field. So these modules were found both on the Canyon website and the United Access Store. So to give object representing this plan and authorize a target such that the player will be destroyed upon collision with these objects. So you can here see that the base, the shape, over here the moon. You have the space battle in the environment. So for the audio part, we'll add 2 areas for this simulator. One laser is filled, a blazing sound is played. Additional, when a ship or turret explodes, explosion takes place. So this audio feedback helps to increase simulation without adding so much noise that the scenes become unpleasant. Okay, for the lighting part, our project uses a single direction light for ABCs. Additional for the point light are added as appreciate to enhance the visibility and the realism. So the point lights are on the base and on the shape enhanced. So for the point light, we need to change some color for point light. Sometimes for the green color is for the players, the red are for the enemies, and the blue are for the allies. So change the color of the light they have in a team-based environment to enable a player to better understand which ship or turret is shooting by the color emitted at great distance.
With lighting, we added point lights to each of the lasers. They are varied by color, red for the enemies, green for the individual players, and blue for allied. Uh, What this animated shot here is showing us, you can see as the lasers from enemies following the player fly over the base, they emit a glow. Uh, those colors were modified along with the materials as the laser is instantiated.
So for the input part, a player is configured to control their shape using the keyboard control, and to turn left and right, the player might be use either the A and D key, or they can use the left arrow and the red arrows. So you can see there the highlight here for the red highlight. It's WASD to control, and the arrow part we can use it to control the shift to left, right, up, and down, and we use the key Z and C to control the speed of the ship. For Z is to increase the speed, for C is decrease the speed. When you want to fail with some enemies, you can use the highlight, the blue highlight here, the space key, and you press space key, you will fight with enemies. So Mike will talk about something else about our project.
With our sensor implementation, we used a combination of trigger colliders, rigid body colliders, and raycast interactions. We'll discuss raycast interactions a little more in depth later, along with the collision avoidance and targeting versus waypoint selection techniques that we use, along with the ship animations. Mainly what I want to focus here on is the spherical trigger collider and the box trigger collider. They're going to operate in a similar fashion. However, the shape's going to be the main difference. We chose a box collider for the turret proximity sensor. Uh, this allows us to better simulate the field of view for the turret. How these trigger colliders work is they're set with a trigger property. Uh, they look for any other collider, such as another non-playable character ship, enemy or allied, or a player ship, to enter their field. And once they enter the field they are kind of a candidate to be a target. If a candidate's not assigned as a target already, it's going to check to see if the team of the player or the ship that entered its proximity sensor is allied or enemy, and it will decide to pursue it accordingly. Rigid body colliders work a little bit differently. They don't have any sort of trigger property assigned. Uh, an example of that is going to be our planet collider. What happens is when you have a ship and its collider collide alongside a object such as a planet or asteroid, it's going to prevent the collision. It's going to enforce a collision. It's not going to allow the ship to fly through the other object. Next, we're going to talk about remote procedure calls and synced variables. It's often referred to as RPCs and sync vars. What each of these do is they kind of allow you to sync the state of play across a server and its connecting clients. Now, each connecting client is going to have a local object that it owns. In our example, it's going to be the player ship. What remote procedure calls do is they allow a function to get called by the server to every single client. Whereas a synced variable is really just syncing a variable's value every so often across the network. In the case of enemy position, it's important to interpolate movement over time. This allows you to have less of a choppy view as time goes on, especially with a slower network connection as latency would set in. Now, the remote procedure call is going to be a little bit different. It's set up similarly to a function you might normally see. The main difference is going to be your argument that passes in. Instead of just passing in an integer damage, what Forge networking requires is to take their class of RPC args and pass in kind of their list of arguments, if you will. So it's just one little extra step to call the next integer argument, assign that to damage, then you apply the health as shown here. It's a little bit different in how you call an RPC. So each object synced on the network is going to have its own network object property. what that can do is it has a function called send RPC. You call set health to all buffered receivers. And what buffering means is that you can kind of more accommodate late joiners to a game. Say the host were to start a game, get in, 3 enemies are destroyed, and then the first player joins shortly thereafter. Now, if we didn't sync this, they would still see 20 ships in their local view of the screen. Buffering allows us to copy the state changes over time and send those updates to a new joining player who joins late. That way they can see the same exact scenario as the server sees. The third property that gets called with this is the one and only argument for set health. That's going to be the amount of damage applied by the laser. Alternatively, you can assign a hard-coded value. It was safe to do in this case for objects like planets or asteroids, which have a tag of planet. So if that object that gets collided with is a laser, it's going to take the laser's damage and apply that to whatever collided with it. If it was a planet, however, it's really going to destroy the planet because most entities' health is only set to a value of a positive 100. Now we're going to assess animations. First, we're going to talk to the non-playable character ships, which are the enemy and allied ships we discussed before. Now, I'd mentioned briefly another form of trigger or sensors that we used were raycasts. And you can see that really clearly on the screen here. Each of the allied ships that are flying to battle have 2 forward-facing rays and 2 perpendicular rays that are shooting outwards to detect whether there's another object in place. Now, if there is, it's going to say, hey, maneuvering's required. If maneuvering's required, it's going to keep moving to where it avoids whatever object is triggered its ray. And once that's complete, it's going to then see, hey, do I have any targets assigned and available? If so, I'm going to move to the target and pursue it and hopefully kill and destroy that target. As it's moving to the target, it says, hey, is the enemy or a ship or a turret out of its range? If so, it's going to clear the target and select a waypoint. If not, it's going to go back through this loop, say, hey, is maneuvering required? Because collision avoidance is the preference for a ship like this. Now, if it did not have a target available, it's going to continue just moving to a randomly selected waypoint. Every so often, it's going to check to see, hey, is there an enemy ship or turret within range? If so, that becomes the new target, and you go back through this loop. Next, I'm going to talk about the turret operator and its animation. Now, what it has is a panic mode, as we call it. As these little turret operators' turrets get destroyed, they are left standing there as the base disappears in an explosion. What that does, when that's set, a panic mode Boolean is set to true, and panic mode commences. They'll select a waypoint, which is effectively picking a position within a unit sphere, and it selects coordinates along this navigation mesh. Now, you can't really see it in this photo, but it's really just the surface of this space base. It's going to take that randomly selected point within the unit sphere and say which coordinates on the nav mesh are closest to it. And it's going to move there until it's within a certain short distance of the coordinates the waypoint is assigned. Once that happens, it's going to select a new waypoint. What this does is it simulates kind of a random motion. And additionally, to kind of help further sell the emotion, you can see here the enemies are kind of running around with their arms waving as if they're panicked. Before we go into the demonstration, I'll kind of cover win-loss rules. It was mentioned briefly that if all enemy ships and turrets are destroyed, you have a win condition, and when all allied forces are destroyed, you have a loss condition. In order to provide that feedback, we really update the heads-up display as shown here. It shows, congratulations, you have won, the timer's set to stop, and the game effectively stops updating the heads-up display from that point in time. Next, we're going to show the demo. A brief overview of system requirements. Since we were able to use low poly models and not a whole lot of really advanced graphical effects are available in Unity, we were able to test this on older hardware running under Linux. This laptop I use is about 8 or 9 years old, and it ran fairly well. Pretty much as long as you have an entry-level graphics card and you have Windows 10, if you can run Windows 10, you're going to be able to run this application, which is nice because it allows more people to be able to use this application.